Today we're going to do lesson 6.7, and this lesson is about recursively defined sequences. So we're doing some more with sequences. So before we get into today's lesson, I want to review a couple things, all right? First of all, before Christmas, and we talked about this a little bit yesterday, we worked with arithmetic sequences. And I'm going to give you a few notes that we don't have. So add these to your notes somewhere, especially if you don't remember a lot about arithmetic sequences. All right. If you remember yesterday, we talked about how to find the common difference. So somebody raise your hand and tell me how we find the common difference. Very good. So the common difference, and again, we added this to our notes yesterday, but if you want to add it again, you can. The common difference is found by the second term minus the first term. All right. The second term minus the first term. And we're going to see this again today, so I want to make sure that you remember it. Now, there was also a formula that you learned before Christmas, the arithmetic sequence formula. Does anybody remember the arithmetic sequence formula? The arithmetic formula. Okay, the arithmetic sequence formula. So this would be another good one to add to your notes. It was a sub n equals a sub 1 plus n minus 1 times d. All right, so that was arithmetic. Now, yesterday, we learned how to find the common ratio. Who can remind us of how we find the common ratio? Very good. The second term divided by the first term. So it's still the second term and the first term, but for the common ratio, we have to take the second term and divide it by the first term. And what was the geometric sequence formula that we learned yesterday? Paris. Is a sub n equals a sub 1 times r raised to the n minus 1. All right, so these are the four formulas that we have learned so far. And if you look at today's lesson, these are called our explicit rules. And I have not used that word, all right, but I need you to understand that the two formulas that we just wrote down on that piece of notebook paper, okay, the a sub n equals a sub 1 plus n minus 1 times d, and then the a sub n equals a sub 1 times r raised to the n minus 1, those are called our explicit rules. Okay, these allow us to find any term in the sequence that we want to, and that's what we've been doing. It's told us to find the 6th term or the 10th term or the 22nd term. Those formulas allow us to find any term in the entire list. That's our explicit rules. Today, though, we're going to learn recursive rules, and those allow us to find the next term in the sequence only. So we can only find the next number in the sequence with this formula. Now, before you panic and think, oh my word, there's 2 new formulas that I have to memorize, I want you to look at the recursive rule for the arithmetic sequence and the recursive rule for the geometric sequence. In both of these formulas, we have to start by identifying the first term, which shouldn't be too difficult, especially if we have a list, right? We look at the first number, we've got our first term. But look at the recursive rule. What is the only difference? If you look at these rules very, very closely, there's one difference. What's the only difference between the two? Joseph. They both have a sub n equals, they both have a sub n minus 1, right? But in the arithmetic sequence, we are adding d, the common difference, and in the geometric sequence, we are multiplying r, or the common ratio. So before you panic about another formula to memorize, these two should not be that difficult. The only difference is the arithmetic, you're adding the common difference. For the geometric, you're multiplying by the common ratio. Now, I also want you to look at the formula. If I'm doing n minus 1, we all know that the n stands for the what? N stands for the position, right? So if I'm asking you to find the third term, we're going to plug a 3 right here, right? So what is 3 minus 1? 2, which means a sub 2. They want the second term. Once we plug in the second term, then we're going to add the common difference, and that'll help us find the third term. So this little part of the problem right here where it says a sub n minus 1, that essentially is taking us to the term right before the one we're trying to find. Now, I'm saying a lot, so let's put it into practice. example number 1, write the first 6 terms of the sequence. But you look at letter A, which term have they already given us? Good. The recursive rule will always give us the first term to begin with. So I've already got a sub 1, which means I just need to find the second, the third, the fourth, and the fifth. Now we're going to do this the long way so that you can all visualize what is happening here. And then I'll show you a shorter way to do letter B. But everything I put on the screen, make sure you get in your notes. All right? So a sub 1, and let me go ahead and change this to white so you can see it better. Okay? A sub 1 equals 0. All right? We're going to write that down just to identify it. Now we're going to find a sub 2, and that's going to equal, all right, I've taken the recursive rule and I've put a 2 right there. So now let's plug in the rest of the problem. It equals a sub n minus 1, which is going to be 2 minus 1, and then minus 8. Now let's talk about this for just a second. Is this arithmetic or geometric? I can already tell just from looking at the rule. If I am subtracting 8 from the term before, is it arithmetic or geometric? All of you should be able to answer this. Is it arithmetic or is it geometric if I'm subtracting 8? Arithmetic, right? Arithmetic is adding or subtracting, the common difference. So a sub 2 minus 1 equals, or then minus 8. Now, what is 2 minus 1? Okay, so a sub 2 equals a sub 1 minus 8. Now, we already know what a sub 1 is. What is it? 0. So we're plugging it in. A sub 2 equals 0 minus 8. So a sub 2 equals, what's 0 minus 8? Negative 8. And box it in. There's our second term. All right, a sub 3 equals a sub, the n is 3, so 3 minus 1 minus 8. Guys, what is 3 minus 1? 2. So we're going to take a sub 2, subtract 8. What was the value of a sub 2? Negative 8. So plug it in. And what is negative 8 minus 8? No, negative 8 minus 8. Very good. The signs are the same. Signs are the same, so we add and keep. All right? That's a sub 3. All right, let's go up here and do a sub 4, which is going to equal a sub 4 minus 1 minus 8. What is 4 minus 1? 3. So a sub 3 minus 8. Okay, what was the third term? Negative 16 minus 8. So a sub 4 equals negative 24. Very good. All right, a sub 5 equals a sub 5 minus 1 minus 8. What is a sub 5? Or I'm sorry, what is 5 minus 1? A sub 4. What was the value of a sub 4? Negative 24 minus 8. So a sub 5 equals negative 32. Awesome. And we got one more because it asked us to find the first 6. So a sub 6 equals a sub 6 minus 1 minus 8. What is 6 minus 1? 5. And what was the fifth term? Negative 32 minus 8 makes our sixth term equal to what? Negative 40. So, that's a lot of work, right? But that is the recursive rule. We use the number, the previous number, and then we add or subtract the common difference. So we've got our first 6 terms, and we should even go back here to a sub 1 equals 0 and box that in. All right, so we've got our first 6 terms. But do you see the pattern? All they did was take the number right before the one they're trying to find, plugged it in, and subtracted the 8. So when we move on to letter B, let's speed this process up just a little bit. What is the first term? Negative 36, all right? They gave it to us, so let's box it in. Now, this one, if we look at the rule, is it geometric or is it arithmetic? How do we know it's geometric? You've got, well, it's not that it's necessarily a fraction, but what are you doing with that fraction? Multiplying it, right? 1/2 times the a sub n minus 1. So 1/2 times the previous term. So this lets me know it's geometric. All right, now let's look at a sub 2. Now without doing all that work, what value are we going to plug in? Well, first of all, it's 1/2. We got to put that first. It's 1/2 times the previous value, which was what? -36. So a sub 2 equals, what's half of -36? -18. Awesome. All right, box it in. So for the third term, we're supposed to do 1/2 the previous term, which is, what was the previous term? -18. So what's half of -18? -9. Good. Okay, for a sub 4, what was the previous term? We're doing 1/2 times the previous term, which was -9. So the fourth term is what? Give me an improper fraction. Don't give me a decimal. Give me a fraction. -9/2. Awesome. All right. The fifth term. We're going to do half of the previous term, which was what? -9/2. So what is the fifth term? -9/4. And for the sixth term, we're taking half of the previous term. What was the previous term? -9/4. So the sixth term is equal to -9/8. And we're done. So once we understand what's going on, the fact that we're taking the previous term and we're halving it, this becomes a much quicker process and much easier to do. Okay? Are there any questions on finding the first 6 terms? All right. Now, how to write a recursive rule. So we already know that the recursive rule, the first thing we have to identify with the recursive rule is the first term. So step number 1 is to write the beginning term. Step 2 is to find the common difference or ratio. So this is where what we did yesterday comes back into play. We have to look at the list and we have to find either the common difference or the common ratio. We've got to decide what kind of list we're looking at. Once we figure out if it's arithmetic or geometric, then we can choose the right formula and simply plug in the D or the R. So this should be pretty simple, but let's try it. Example 2, write the recursive rule for the sequence. So looking at letter A, let's start by seeing if this is arithmetic. It looks to me like it's arithmetic. I say that because I'm looking at numbers that are pretty small and pretty close together. That's a good indication that we're looking at an arithmetic sequence. Okay, look at letter B. Those numbers get larger and get rather big. So that tells me, and hopefully you, that is probably geometric because we're multiplying by something. So you can try to eliminate having to do so much work if you can look at the list and figure it out. But if all else fails, just go ahead and try arithmetic and then try geometric if you have to. But looking at letter A, if it's arithmetic, we have to find a common what? Difference. Good. So how do we, Cam, how do we find the common difference? I'm going to find the common difference by taking the second term of 3 and subtracting 8. So what does that give me? What's 3 minus 8? -5. Awesome. So I already know, or we're going to try this because remember, we have to make sure that it goes all the way across and it works. I already know that it's going to work on the first two. So let's try 3 minus 5. What is 3 minus 5? -3 minus 5 is -2. What is -2 minus 5? -7. So it still works. So we keep going. What is -7 minus 5? -12. So I see how you found the common difference. I see that you checked it out, made sure it worked, and it does. So what is the first term of this sequence? Because that's the first step. We have to identify the first term. Okay, 8. Very good. So there's my first term. Now, this was a common difference. So are we using an arithmetic rule or are we using a geometric rule? Arithmetic. So we're going to write that rule down. Okay, it's a sub n equals a sub n minus 1 plus d. That is the recursive rule formula. So we're writing it down until we've got it memorized. Now we bring down that first term because we know that is part of the rule. And then all we have to do is plug in the difference, the d. What was the common difference? negative 5. So a sub n equals a sub n minus 1 minus 5, and we're done. That is our recursive rule for this list. Okay, so it's not that difficult. We already talked about letter B and how it looks to be geometric, so let's go ahead and see if we have a common ratio. LJ, how do I find the common ratio for this one? Good, I'm going to divide 20, the second term, by 4, which is the first term, and so that equals what? 5. All right, let's test it out. We know it's going to work on the first one. What is 20 times 5? 100. What's 100 times 5? 500. And what's 500 times 5? 2,500. So it works. So let's go ahead and start writing our rule. First of all, what is our first term? 4. And is this geometric or arithmetic if we have a common ratio? Geometric. So let's write that formula down. It's a sub n equals r times a sub n minus 1. So what is the only thing that we have to plug in, Renier, to this problem? R, which is? So a sub n equals 5 times a sub n minus 1. And you're done. That is the recursive rule. That's the end of your notes. So I want you to put your pencil down. I'm going to show you one more type of problem because I want you to understand. Sometimes you see a problem presented to you in a different way and you think, I can't do this. Ms. Johnson did not work a problem like this with me. I don't know what to do. But I want to show you that you do know what to do. All right? If I asked you to write an explicit rule for the recursive rule. Now, again, as a quick reminder, we talked about the explicit rules at the very beginning. All right? The arithmetic one was a sub n equals a sub 1 plus n minus 1 times d. And then a sub n equals a sub 1 times r raised to the n minus 1. All right? These are our explicit rules. So if I'm asking you to look at a recursive rule and write an explicit rule, we still only need 2 pieces of information. So looking at the arithmetic rule, what are the 2 pieces of information we need to plug into that formula? We need a sub 1 and we need d if we're going to write the arithmetic explicit rule. What 2 things do we need if we're going to write the geometric rule? The r and the a sub 1 again. So let's go down to letter A. Do they give us the first term? Yes, they already gave us the first term. If we look at letter A, we've got a sub 1 equals negative 45. So they've already given us half of what we need to write this rule. The second thing we need, though, is either the common difference or the common ratio. So if you look at the recursive rule, there's only one number in it. So we should be able to figure out pretty easily, is that a common difference or is that a common ratio? So Renier, plus 20, is that a common difference or a common ratio? Say it again? Yes, the plus 20, is it a common difference or a common ratio? If they're adding 20 in this recursive rule, it's a common difference. So we are going to write an arithmetic explicit rule. So if we bring down that formula, it's a sub n equals a sub 1 plus n minus 1 times d. And let's plug in what we know. What was a sub 1? Negative 45 plus n minus 1. And what was the common difference? 20. Now, do you remember before Christmas, did we go any further than this when it was arithmetic? Yes. What did we do? Distributive property. We can go further with this one. So a sub n equals negative 45. We distribute the 20 and we get plus 20n minus the 20. And then what could we combine? Negative 45 and negative 20. So we brought down the 20n, combined those, and got negative 65. So there is your explicit rule, and you wrote it from the information in the recursive rule. Okay? So just because it's presented to you different doesn't mean you can't do it. Now look at letter B. Do we know the first term? Yes, it's right here. A sub 1 equals 13. Okay? Blake, we've only got one number in the recursive rule. Is it a common ratio? What is it? And is it a common ratio or a common difference? It's negative 3. Is it a ratio or is it a difference? It's a ratio. We know that because they are multiplying it, right? So the rule is a sub n equals a sub 1 times r raised to the n minus 1. So what is a sub 1 that we're going to plug in? 13. What is the common ratio we're going to plug in? Negative 3. And of course, with this one, we raise it to the n minus 1, and we cannot go any further. So we're done. We just wrote an explicit rule from the recursive rule. All right? That is lesson 6.7.